Welcome to Scientific Journeys, everyone. I'm Jack, and today we are diving into one of the most fascinating stories in scientific history, a tale that feels surprisingly relevant to our times. Joining me today is Professor James Thomson, a renowned historian of science who spent years studying the life and work of Isaac Newton. James, welcome to the show.
Thank you, Jack. It's great to be here, especially to discuss Newton, whose story never fails to amaze me, even after all these years of studying him.
You know, James, I think many of our listeners might relate to this. Imagine being forced to leave university and return home during a pandemic. Sound familiar? Well, for Isaac Newton, this led to what might be the most remarkable year in scientific history.
That's absolutely right, Jack. And what makes this story even more fascinating is that Newton wasn't born into the scientific elite. He was actually born prematurely on January 4, 1643, into quite humble beginnings on a farm in Woolsthorpe, Lincolnshire.
I understand his early life wasn't exactly smooth sailing either, right?
Not at all. His father died before he was born, and his mother remarried when he was 3, leaving young Isaac in the care of his grandmother. This early separation really shaped his personality. He became quite solitary and introspective.
It's interesting how these personal circumstances often shape scientific minds. But let's talk about that famous period, the plague years of 1665 to 1666. What made this time so special?
The Annus Mirabilis, or the Year of Wonders. When the plague forced Cambridge to close, Newton returned to Woolsthorpe Manor. But unlike many who might have seen this as a setback, Newton turned this period of isolation into perhaps the most productive time of his life.
It almost sounds like a silver lining to a very dark cloud. What exactly did he accomplish during this time?
During these months of isolation, Newton laid the groundwork for what would become his most groundbreaking discoveries. He began developing calculus, conducted his revolutionary experiments with light and prisms, and yes, that's when he started contemplating universal gravitation.
And that brings us to perhaps the most famous Apple story in history. But I hear the real version is quite different from what most people think.
Indeed. The popular image of Newton being hit on the head by an apple is actually a myth. What really happened was far more interesting. Newton later recalled watching an apple fall from a tree in his garden, which got him thinking about why objects always fall straight down toward Earth's center.
So it was more of a moment of contemplation than a comedic bonk on the head.
Exactly. And this is where Newton's genius really shines. He made the revolutionary leap of wondering if this same force that pulls the apple down might extend all the way to the moon, essentially keeping it in orbit. It was the first time anyone had suggested that terrestrial and celestial mechanics might follow the same rules.
That's fascinating. You know, it reminds me of how we often talk about having our own lightbulb moments, though I suppose in Newton's case, it was more of an apple moment. But what I find really interesting is how he approached these discoveries with such humility.
Absolutely. One of his most famous quotes really captures this: "If I have seen further, it is by standing on the shoulders of giants." He wrote this in a letter to Robert Hooke, acknowledging that scientific progress is built on previous discoveries.
Speaking of his scientific work, let's talk about his experiments with light. I understand these were just as groundbreaking as his work on gravity.
Oh, definitely. Newton's work with prisms was revolutionary. Before him, people thought white light was pure and that prisms somehow added color to it. But through careful experimentation, he proved that white light actually contains all the colors of the rainbow.
And didn't he build his own telescope to solve some practical problems with the existing ones?
Exactly right. The telescopes of his time suffered from chromatic aberration, colored fringes around images caused by different wavelengths of light focusing at different points. So Newton invented the reflecting telescope, using mirrors instead of lenses to focus light. It was a brilliant practical solution that's still used in most modern telescopes today.
You know what strikes me about all these discoveries? They seem to share a common thread: Newton's ability to look at everyday phenomena and see something deeper. Whether it's an apple falling, light through a prism, or a telescope's limitations.
That's a brilliant observation, Jack. Newton had this extraordinary ability to observe the ordinary and extract the universal. His laws of motion, for instance, arose from carefully observing how objects move in everyday situations.
Could you break down these laws for our listeners? Maybe explain them in a way that relates to our daily experiences.
Think of Newton's laws as like traffic rules for the universe. The first law, an object in motion stays in motion unless acted upon by an outside force, is why we wear seatbelts. The second law, force equals mass times acceleration, explains why it's harder to push a loaded shopping cart than an empty one.
And the third law? The famous every action has an equal and opposite reaction.
That's the one that explains why rockets work. When the rocket pushes exhaust gases backward, the gases push the rocket forward with equal force. In fact, every time you walk, you're using this law, you push back against the ground, and the ground pushes you forward.
It's amazing how these principles that Newton discovered during his isolation are still so relevant today. I mean, our smartphones use his principles for their accelerometers, GPS satellites rely on his gravitational theories.
And speaking of isolation, isn't it remarkable how this parallels our recent global experience with the COVID-19 pandemic? Many people found themselves, like Newton, forced into isolation, and some used that time for remarkable creativity and innovation.
That's such an interesting parallel. Do you think there's something special about isolation that can spark creativity?
I believe there is, Jack. Isolation removes many of the usual distractions and social pressures that can inhibit deep thinking. Newton, being naturally introverted, thrived in this environment. It gave him the mental space to fully develop his ideas.
Yet despite all these incredible achievements, Newton remained remarkably humble about his work. Was this genuine humility, or was there more to it?
It's fascinating you ask that because Newton was actually quite complex in this regard. While he did make humble statements like the shoulders of giants quote, he could also be fiercely protective of his work and engaged in several famous disputes with other scientists.
Ah, the human side of genius. Could you tell us about some of these disputes?
The most famous was his lengthy controversy with Leibniz over who invented calculus. Both men developed it independently, but Newton was extremely protective of his priority. It shows how even the greatest minds can have very human reactions to questions of recognition and priority.
It's almost comforting to know that even Newton had his moments of professional rivalry. But let's talk about his legacy. How do you think Newton would react to seeing how his discoveries are used today?
I think he'd be amazed, but not entirely surprised. Newton had this remarkable ability to see the universal in the particular. When he described gravity, he wasn't just explaining falling apples, he was describing a force that governs everything from ocean tides to spacecraft trajectories.
And speaking of spacecraft, it's incredible how his laws of motion and gravity are still essential for modern space exploration, isn't it?
Absolutely. Every time we launch a satellite, send a probe to Mars, or calculate the orbit of a space station, we're using Newton's equations. While Einstein's relativity gives us some refinements for extreme conditions, Newton's physics is still what gets us to space.
As we wrap up our discussion, what do you think is the most important lesson modern scientists and innovators can learn from Newton's story?
I think there are several vital lessons. First, great breakthroughs often come from having the time and space to think deeply. Second, observation of everyday phenomena can lead to universal insights. And perhaps most importantly, even groundbreaking discoveries build on what came before. We all need those shoulders of giants to stand on.
That's beautifully put. And in a way, Newton's story feels particularly relevant today, doesn't it? When we are facing global challenges that require scientific innovation and creative thinking.
Exactly. Just as Newton turned his period of isolation into a time of remarkable discovery, we too can use challenging circumstances as opportunities for innovation. His story shows us that sometimes, the most significant breakthroughs come when we are forced to step back and see things differently.
And I suppose that's really what science is about, seeing things differently and having the courage to challenge existing understanding.
Precisely. Newton's greatest achievement wasn't just his individual discoveries, it was showing us that the universe operates according to universal laws that we can understand through careful observation and rational thinking.
Well, James, this has been a fascinating discussion. Before we wrap up, is there one final thought you'd like to share with our listeners about Newton's legacy?
I'd say remember that even Newton, arguably the greatest scientist who ever lived, acknowledged that discovery is a collective endeavor. Science progresses through both individual genius and building on the work of others. That's as true today as it was in Newton's time.
Thank you, James, for sharing these incredible insights about Newton's journey from a farm boy to history's most influential scientist. And thank you, listeners, for joining us on this exploration of how isolation, observation, and innovation can change our understanding of the universe.